Me and my lab partners created an experiment that would replicate what the gut microbiome in animals would have, and how the enzyme trypsin is active in their intestines and how bacteria is secreted. Um, so basically, what we did was design an experiment that had our optimal. We used temperatures, and we had the temperatures 37, 47, 50, 60, and 70 degrees Celsius. We ran this experiment twice, and the first time we rationale that at 37 degrees Celsius it would be the most optimal. We got our sources from healthline.com, and that's what it said would be the most optimal inside the animal intestine. However, when we ran this experiment, we saw that our data was a little off, and it looked to be more rational at 47 degrees Celsius. So this time around, we made sure that we made those changes and did it at 47 degrees Celsius as our most optimal. And basically, the enzyme trypsin, what that does is it speeds up chemical reactions by lowering the activation energy. Um, the materials and methods that we went ahead and used was 450 microliters of a reaction buffer, and we used NaCl. It was 0.15 moles of that, and we used a pH of 8. We used 500 microliters of the substrate azocasein, 50 microliters of the enzyme trypsin, and then again our temperatures were 37, 47, 50, 60, and 70 degrees Celsius, and we made 4 replicates of each temperature. The reason for the replicates is because if one were to do something um, that was significantly off from the other sets of data, we would be able to see that something went wrong and be able to have more variability and averages and measurements and read our results a little better if something again were to go wrong. We incubated our replicates for 20 minutes in the centrifuge, and then after that got done, we immediately did 500 microliters of 10% TCA. And basically, what TCA does is it stops the reaction from happening. So we centrifuged it for 2 minutes, and then it separated the pellet from the supernatant. And basically, the TCA stops the reaction and it precipitates undigested substrates from the pellet. And the supernatant is the liquid that's at the top. The pellet at the bottom is like the protein that was left over. Azocasein, which is basically what this whole process is on, is a milk protein with sulfanilamide attached, and that allows it to absorb at 440 nanometers. Um, Basically, when we put it in the spectrophotometer, our absorbance reading was at 440 nanometers, and we had negative controls. We had 4 of those at 47 degrees Celsius, and for those we didn't add any trypsin. And again, that basically shows us that at a certain range, if something were to go wrong, what they looked like originally. And it makes for better results. That way we kind of know what's going on. Basically, for our results, hold on, sorry. For our results, we got the absorbance at 47 degrees Celsius was not significantly different from the absorbance at 37 degrees Celsius. And our p-value was significantly different. And then at 47 degrees Celsius, from the absorbance from 47 to 50 degrees Celsius, it was significantly different, but there was also the result was no significant difference for that one. And then 47 to 60, it was significantly different. 47 to our 70 degrees, significantly different. And then the absorbance at 47 to our negative controls were significantly different. So we did have really good results this time around going through compared to our first one. From 47 degrees Celsius to 50 degrees Celsius, you can see that our p-value was greater than our 0.5. And then from 47 versus the 60, 70, and 37, our p-value was a lot smaller than our 0.5. You can also see that in our results, the trypsin with our t-test, you could see these variances that the 47 and 70, the 37, they all have significant differences between them, all except for that 47 to 50 degrees Celsius. So basically, to recap, our hypothesis was that if the temperature reached the 47, then the trypsin activity would decrease. And our experiment consisted of 5 different temperatures. Again, that was the 37, 47, 50, 60, and 70 degrees. And we made sure that we didn't make the same mistake twice. For this experiment, the 2 group members added the TCA into the centrifuge tubes to make sure that it did not become another variable like we were concerned with last time. We also made sure that the centrifuge tubes were completely in the water baths to make sure they were at the right temperature, because the first time we ran it, they looked like they were a little bit popped out. So our conclusion is relevant because we have the ideal conditions to grow bacteria, which made this experiment successful in the end. And just so that you can see a little better, that's our materials and methods and our T results, and our absorbance readings, our standard deviations, and our discussion. And that is it.